Hello, grade 11 chemistry class. Welcome back to another lesson on the chemical reactions unit. In today's lesson, we're going to learn how to calculate the molar mass of various substances. But before getting into that, we're going to just do a quick review on the previous lesson. And remember from the previous lesson, we looked at the concept of a mole, and we defined a mole as a unit of measurement that is equal to 6.02 times 10 to the power of 23 particles. And so when we talked about particles, we said that this could be atoms. And so when we look at, for instance, a mole of any element, we're saying that we have 6.02 times 10 to the power of 23 atoms. So if we had 1 mole of carbon atoms, that's equivalent to having 6.02 times 10 to the power of 23 carbon atoms. And we refer to this number as Avogadro's number. Okay, so a quick review question from the previous lesson. Go ahead, pause the video, and see if you can calculate the correct answer for this problem. So the question states that if you have a container with 1 mole of sulfur and another container with 3 moles of potassium, how many atoms of sulfur and potassium do you have? Well, we know that we have 1 mole of sulfur, so we automatically know that we have 6.02 times 10 to the power of 23 sulfur atoms. However, the question states that we have 3 moles of potassium. So what we need to do is multiply the Avogadro's number, so 6.02 times 10 to the power of 23, by 3. And when we do that, we'll get a value of 1.81 times 10 to the power of 24. And so our answer for this question is C. Okay, so what is molar mass? Molar mass is the mass in grams of 1 mole of a substance, and the units that we use to represent molar mass are grams per mole. The molar mass for any element is provided in our periodic table. So how do we locate the molar mass of an element? Well, it's quite simple actually, and we'll go through a couple examples here. So our first example is to look at the molar mass of hydrogen. So when we look at the periodic table, we can see here we got the element symbol, and then we got the name hydrogen, and underneath the name we have a numeric value. So this value here is our molar mass. So our molar mass of hydrogen is 1.01 grams per mole. Don't forget the units when we are looking at molar mass. Okay, so now the molar mass of nitrogen, we can see here underneath the name nitrogen, we have a numeric value. That is our molar mass. So for nitrogen, the molar mass is 14.01 grams per mole. So now we're going to look at the steps on how to calculate the molar mass of an element. The first step is to determine the chemical formula of the element. In this case, when working with just elements, the chemical formula is just the chemical symbol. So for example, if we're to look at magnesium, the chemical formula is the symbol which is above the name magnesium, so it's Mg. The second step is to use a periodic table to calculate the molar mass of the element. Again, we know our molar mass of an element is just that numeric value underneath the name of the element. So for magnesium, it's 24.31 grams per mole. Now, when we're dealing with diatomic elements, if you ever have to calculate the molar mass of a diatomic element, we know that the formula for that has 2 subscript. So we need to multiply the molar mass by 2 because we have 2 atoms. So if we're to calculate the molar mass of hydrogen, which is a diatomic element, we look at the molar mass, which is 1.01. And so we have H2 here as our chemical formula. So we're saying we have 2 hydrogens. So H2 equals 2 hydrogen, which equals 2 times our molar mass of 1.01. And that's going to give us a total of 2.02 grams per mole. Next, we're going to look at how to calculate the molar mass of chemical compounds. And so the first step is the same as for calculating the molar mass of an element. It's going to just be determine the chemical formula of the compound. So if we're to look at hydrogen chloride. To determine the chemical formula, remember our crisscross method that we learned a while ago, in which the number of charge for each element becomes a subscript for the opposite element. So for hydrogen, we have an ionic charge of +1, so that 1 becomes a subscript for after chlorine. And then for chlorine, we have an ionic charge of -1, so that 1 becomes a subscript after hydrogen. And so we don't need to represent ones here, so we can just write HCl. So our formula for hydrogen chloride is HCl. Our second step is to use the periodic table to determine the molar mass of each element in the compound. So we know that hydrogen is 1.01 grams per mole and chlorine is 35.45 grams per mole. Third step is to multiply each element's molar mass by the number of atoms of that element in the compound. So for hydrogen, we know that we only have one hydrogen in hydrogen chloride. So we just multiply our molar mass by 1. And then the same for chlorine. There's only one chlorine element in hydrogen chloride. So we multiply its molar mass by 1. And then our final step is to add the molar mass values of each atom in the compound together to get the molar mass of the compound. So what we do is we represent the chemical formula. So HCl equals 1.01 plus 35.45, and we get a total of 36.46 grams per mole. Okay, so now we're looking at our first example. It says to calculate the molar mass of carbon dioxide. So our first step is to determine the chemical formula, but in this case, it's already provided to us. The chemical formula of carbon dioxide is CO2, so we can just move on to step number 2. So step number 2, we're going to look at the molar mass of each element. So for carbon, it's 12.01 grams per mole, and for oxygen, it's 16 grams per mole. Okay, so now we need to multiply the molar mass by the number of atoms in the compound. So we only have one carbon, so we multiply by 1. And then for oxygen, we see that we have two subscript after oxygen, so we have 2 oxygens in the compound. So we need to multiply that molar mass that's provided in the periodic table by 2. And then finally, we write our chemical formula, and then we add the molar mass for the atoms, and we get our total here, which is 44.01 grams per mole. Our second example is what is the molar mass of ammonium nitrate? So in this case, again, the chemical formula is provided, so we don't need to worry about step 1. So for step 2, we're going to look at the molar mass of each element. So for nitrogen, it's 14.01 grams per mole. For hydrogen, it's 1.01 grams per mole. And for oxygen, it is 16 grams per mole. Again, our next step is to multiply our molar mass by the number of atoms present in that compound. So we can see here that we have 2 nitrogens in this compound. So we need to multiply the molar mass from the periodic table by 2. For hydrogen, we have 4 hydrogen atoms in the compound, so we need to multiply its molar mass by 4. And then for oxygen, we have 3 oxygens in the compound, so we need to multiply the molar mass from the periodic table by 3. And then finally, to calculate the molar mass of the compound, we're going to add all these values up, and we're going to get 80.06 grams per mole. Okay, so now looking at the last question, we are wanting to calculate the molar mass of potassium sulfate. So you can see here, we don't have the chemical formula. So the first thing we need to do is find the chemical formula. So we know that potassium, when we look at that on the periodic table, the element symbol for potassium is K, but sulfate is a polyatomic ion. So we need to refer to our common polyatomic ions table, and we need to look for sulfate. And so when we do that, we can see on the right-hand side here, we see sulfate, and then we can see here that sulfate is SO4 2 minus. And so when we write that out, we do the crisscross method to figure out what the chemical formula is. And so when we do that, we have a 1 here and a 2 here. But remember, for polyatomic ions, we do not separate any of the elements. So this 1 plus charge is going to go here. So we have 1 go here and a 2 go here. And so when we write out this chemical formula, we have a 2 subscript after potassium and a 1 subscript after sulfate. But we don't need to keep this 1 here because we're multiplying SO4 by 1. So we can just write it out as K2SO4 without the brackets. Okay, so now we have the chemical formula. So now the next step is to calculate the molar mass of each element. So we can see from the periodic table, the molar mass of potassium is 39.1 grams per mole, sulfur's molar mass is 32.06 grams per mole, and oxygen's molar mass is 16 grams per mole. So now we're going to need to look at the chemical formula and multiply the molar mass of each element by the number of atoms present in that molecule. So we have 2 potassium, so we need to multiply this molar mass by 2. For sulfur, we only have 1, so we just multiply the molar mass by 1. And for oxygen, we have 4, so we need to multiply its molar mass by 4. And now to figure out the molar mass of the potassium sulfate compound, we're going to add all of these values up, and that's going to give us a total of 174.26 grams per mole. Okay, so that is it for today's lesson. So here are some practice questions. Please try these out at home and do your best. And then in the next lesson, we will start out by going over these problems. Thank you for listening, and I hope you enjoy the rest of your day.